point C is central to the pattern of the light, and darkened bands on the screen. This slit separation 0.1 millimeters, right? And the distance between two slits, right? Distance between two slits and the screen is 2 meters. The band at the point C is bright band. Explain why the band at point C is bright, and why this is a dark band to the left of the center. What's that? Explain why the band at point C is bright and why there is a dark band to the left on the center, left of the center. So now, would you be answer to that question with the current knowledge? So you are free to draw a diagram if you want. Yeah. So now can you put what you learn into words and make an answer on the board?
Okay. It's not letting me like write.
Yeah. I just want to. It's a training to, so your V.C.E exam. So I just want to. So what mistake you do, and watching how do you do that. So then catching up any weakness.
But like it's not letting me like write anything down with the like pen.
You can use the pen, yeah? Can you?
It's not working.
It's not working?
Yeah.
Or you can type and paste if you like.
Okay.
Yeah. So you said explain why the band at point C is bright and why there is a dark band to the left of the center. The bright band is due to the constructive interference. Yeah, good. The dark band is due to the destructive interference. Cancel out the light waves. Yeah, so then you can actually draw a diagram you're free to do that. To explain what did you mean, right? So constructive interference. So you can say See, that is a constructive interference. They're putting on top of each other. Right? So destructive interference, we can get this point. Agree?
Yeah.
So in this point, that is the overall interference. So cancelling effect. So in here, what happened? Amplifying effect. So this is cancelling effect. This is amplifying effect. Right? So amplifying effect would resulting right bright zones and cancelling effects result dark zones. So is that more clear now? So next part will say the experiment performed by the student is often described. This Young's experiment, I forgot his name. The Young is the one did that double slit experiment. Remember, Young actually done two different experiments, right? The first one is one of them is a double slit experiment, the one we discussed today, right? But there's a single slit experiment is a different one. So this is the waveform. Actually, this waveform of light, right, explained by this experiment, and we can calculate lambda, right? So we can calculate many other things by this experiment. But then other experiment he done only a single slit. All right. So that is also in your curriculum. So in that single slit experiment, describing a different phenomenon. It's don't mix up these together. That's what I'm telling you. The single slit experiment is a different from double slit experiment. The single slit experiment, it is describing a phenomenon of light, another phenomenon, right? In addition to the waveform. So that phenomenon also created by the waveform. That's for sure. But that is called diffraction, right? But we come to that, right? There are rules and calculations coming from diffraction as well, right? Any kind of wave, particles of the wave, right? Going in a waveform, right? So these things are common for those kind of energy transmission waves. Yeah, that kind of. So imagine now, you know that, right? The Isaac Newton also told the light is actually, it has a waveform, right? So it actually have the small packet of energy, right? Small packet of energy moving like a waveform, right? So, and also you know that the alpha rays, gamma rays, we discussed the first part of the physics, remember, radiation. So in this radiation, right, also we learn about the atoms actually, which are the atoms not are stable, right? Their nucleus are not stable, and they emit the energy by the waveforms. And alpha rays, gamma rays. So in those alpha rays, gamma rays, right? What they're moving? The alpha rays, for example, to electrons, to protons and neutrons moving, right? In a waveform, they carry energy. And beta rays, right? The electrons moving. Gamma rays, we don't know, but something is moving. Maybe very little subatomic particle, which is just a fraction of a electron, just a fraction of a proton, because we don't know protons also made out of certain other material, right? Other small particles. So one of those moving, who knows? That is gamma rays. We say that it has no, right? No weight at all. But having said that, there could be very little, negligible and not measurable, small particles. So likewise, right? So in this case, in the light, so still unmeasurable small particles carrying energy, right? So